Howdy, howdy, this is Mr. Potter. In our previous video, we talked about the idea of a queue, the idea that the first thing into a queue is also the first thing out of the queue. And so what I want to talk about today is I want to talk about the Morris sequence. Now the Morris sequence is also called the look and say sequence. So if I was to write a series of numbers, let's say I've got 3, 4, 1. If I write that series on here, then if I look at this from left to right, I would see 1, 3, 1, 4, and 1, 1. So I would write 1, 3, 1, 4, 1, 1. So now this is another sequence. So I can look at this sequence from left to right and notice that I have 1, 1, 1, 3, 1, 1, 1, 4, and 2 1s. But this is also another series that I can look at from left to right, and I can see that I have 3 1s, 1 3, 3 1s, 1 4, 1 2, and 1 1. And the idea is that I can repeat this as long as I want. Each time is going to be a verbal description of what the previous sequence was, written in digit form. So that's what we're talking about when we talk about what is a Morris sequence. So when I'm looking at this idea for a Morris sequence, what I'm going to need to implement here is I'm going to need a way to convert a string that's typed in by the user to a queue. In other words, the elements in this string are going to have to be converted, each one of the characters, to an int, and then those ints are going to have to be put into the queue. I'm going to have to know when to stop. Because if I had a queue like 3, 4, 1, I would put a 3 in the queue, I would put a 4 in the queue, I would put a 1 in the queue, and then I'm going to have to put something in the queue to let me know that I'm done. So that when I take this piece of data out of the queue and put a 1 and a 3 in the queue, then I take this next piece of data out and have a 1, 4, and take this next piece of data out and have a 1, 1. I know that this is my terminator, and probably the best thing to have for a terminator would be a 0. The idea is that after I've entered in the string, if I just put a 0 in here, I'm never going to say that I have 0 of anything, because I could say that I have 0 of everything, except for whatever digit I'm looking at. So I'm never going to have 0 in my Morris sequence, so I'm going to go ahead and use that as a terminator for my Morris sequence. So I'm going to have a terminator, and then I'm going to have logic to make the next sequence. So looking back at the example we just had, if I'm looking at this sequence, I'm going to read in this 1, and then I'm going to have to look at the next one and say, oh, it's a 1 as well. My count is going to go up to 2. Then I look at the next element, oh, my count goes up to 3. I look at the next element, it's like, oh, that's different. So this 3, along with the contents, get pushed. And now my count resets back to 1. And I'm going to have to keep track of a count variable as well as the data itself, because each one of these alternate is a count followed by a data, followed by a count, followed by a data, a count and a data, a count and a data, and so forth. So that's what I'm going to be doing inside of a loop, as long as the value that I'm peaking is not 0. So with that being said, that's the idea, that's the logic behind our Morris sequence. Let's talk about how we're going to go ahead and code this. So last time we were talking about the queue. This is our queue test, and we're going to be implementing that file as well. So I'm going to go ahead and call this morris.cpp. We're going to include IOStream because we're going to be printing to the screen. We're going to include string because we're going to be entering a string from our user to our data. We're going to have to go through that string character by character. And we're also going to include arrayQ.h. Okay, So using namespace standard, and we're going to go through here. I need a queue. This is going to be my data structure, and more than one function is going to have to access it, so it's going to need to be a global. And our type is going to be ints, and I'm going to go ahead and call it Morris. And so I'm going to have a function that's going to do our Morris sequence. So void do Morris. And so what this is going to do is it's going to take whatever's in our queue and find out the Morris sequence for that data in the queue. So it's going to take an existing sequence like we had on our first page. Let me go back to there. So it's going to take one of these sequences and develop the next sequence from it. So this green sequence will give me this green sequence. This green sequence will give me this green sequence if I run this do Morris on it. So what we're going to do is we're going to have a variable, so int data equals Morris.dq, and we're going to start our count at 1. And then while Morris.peak is not equal to 0, in other words, that's going to be our terminator. While that's not equal to 0, we're going to do the following. We're going to say int new data is going to be equal to Morris.dq. And if data is equal to new data, notice this is a match. If I have a match, then I want to count plus plus. Else, which means this doesn't match, then I want to do the following. I want to say, hey, I want to put the data that I have so far and the count that I have so far in my Morris queue. So Morris.enqueue count. Remember, the count goes in first. And Morris.enqueue data. So in other words, if I had a 1 and a 1 and a 1, my count is 3, and so I'm going to say that I have 3 1s. So the 3 gets enqueued, then the 1 gets enqueued. And then data is going to be equal to whatever new data is, and my count is going to get reset. So if I match, then I just keep incrementing my count. It's when I don't match that I actually go about and put stuff into the queue. I'm going to put the count that we've been running so far and the data element that we've been counting, and then reset my data element and my counting variable. Now, once I've done this, once I've gone through this loop, now I'm ready to take care of the end. So my last bit of data I'm going to enqueue. So I'm going to say Morris.enqueue whatever my count is at the end. I'm going to Morris.enqueue whatever my data is at the end. And then finally, I need to take care of 0. That 0 is still in my queue, so I need to make sure that I take this 0, which is now at the front of the line, and move him back to the back of the line. So I'm going to say Morris.enqueue, Morris.dq. So that takes the 0 and it puts it back at the back of the line. So now the 0 is a terminator again. So that's the idea behind the Morris sequence, how we're actually going to generate the Morris sequence. So now everything else that we need to do is going to be the stuff to set up the Morris sequence from the string, as well as to output it so that the user can see the results. So let's go ahead and talk about void setup. And what this is going to do is this is going to take the this is going to take whatever the string is and put it into the queue. So what we're going to do is so we're going to have a string input. This is where the user types in their data, so we're going to prompt it. So cout, please enter a Morris sequence. And cin our input string. And then we're going to have to go through this input string. So for int I gets 0, I is less than input.length I++, and we're going to say that we're going to morris.enqueue whatever that character is. So input sub I, but remember that this is a Unicode value. This is an ASCII value, and I need to offset it by whatever the ASCII value of 0 is, which is 48. So minus 48, or minus a 0. And that makes sure that it actually is an int that we put in there. And then finally, we need a terminator. So we're going to morris.enqueue a 0. And so that's how we set up based on our string that was entered. The last thing that our program really needs is a way to output the result. So we're going to do a void output. And the whole idea for this is that we're going to take the data that's in the queue and present it. So while morris.peak is not equal to 0, we're going to do the following. We're going to get that data out. So morris.dequeue. We're going to see out that data. Then we're going to morris.enqueue whatever data happens to be. And then once I've done that, 0 moves its way slowly to the front of the line. When I've completed this loop, 0 is at the front of the line. So we're going to do the same thing that we did before to take care of 0. So morris.enqueue, morris.dequeue. And we're going to see out an end line just to make things nice. All right, so this is our program. This is the logic behind it. So all we need to do is to actually call all of this in a main. So we're going to call on setup. We're going to say for int I gets 0, I is less than, let's say 10. That way we can show 10 iterations of the Morris sequence. It won't be too long, but it'll be enough to show us that the logic is sound, I++. And we're going to do the following. Every time we go through this, we're going to do Morris, and then we're going to output. And then we return 0 because we're a good program. All right, so the idea here is that we've written a function that actually does the Morris sequence. It's going to go through the existing queue. It's going to keep count of how many data values it finds. And as soon as it comes up to a number that isn't the same, it's going to put the data it's accumulated so far into the queue and start counting again from scratch. We're terminating with the 0, so we're always going to make sure the 0 is at the end of our sequence. As we dequeue, whether it's from doing the Morris sequence or our output, our 0 gets closer and closer to the front of our queue, so we need to make sure and pop it off and put it back at the end of our queue when we're done. It's our terminator. We have a way to take whatever input string is and convert it to a Morris sequence, a Morris queue. And so we're going to set up that way before we actually do any processing. So that's the logic behind our code. So let's go ahead and compile. Hopefully don't have too many mistakes. Just a few. Line 18.9. So if I go over here to 18, and that's because I forgot a semicolon here. And the else without the previous if, that's because it didn't read that if. So let's go ahead and save this. And let's compile again, and that seems to work. So we're going to run Morris. So I'm going to run it with the sequence that I had, which was 3, 4, 1. So notice what I've got here. I have 1, 3, 1, 4, and 1, 1. So our sequence is 1, 3, 1, 4, 1, 1. Then we have 1, 1, 1, 3, 1, 1, 1, 4, and then 2 1s. Then this sequence has 3 1s, a 3, 3 1s, 1, 4, 1, 2, and 1, 1. And so the thing that you notice is that this thing does get longer and longer the further out we go. Except if I run the Morris sequence with this. Interesting. What does my original sequence has? Well, it has 2 2s. And then the next time I count, I see 2 2s. And the next time I count, I see 2 2s. And so forth and so forth. This will always give me 2 2s because that's always what's in the cue. Now, another interesting example, if I were to put like 5 5s, if I try and do that, then I end up 5 5, but then I have 2 5s, and then this thing starts exploding the way that we expect it to. So it's not just a matter of if I have the same number of that number, it is going to give me the 5 5 the first iteration, but then I've got 2 5s after that, and then I've got 1 2 1 5, and then this thing just goes and explodes. This will even work if I put in a single number, like 3. So notice here I've got 3, then I've got 1 3, then I've got 1 1 1 3, then I have 3 1s and a 3, then I have 1 3 2 1s and a 3. And there are interesting and beautiful patterns in this. So I do encourage you to try and run with it, experiment with different inputs, and see what you can come up with. So once again, this is Mr. Potter. Thank you for watching. Have a great day.